Before we proceed to next section, one more very quick example how you can use long division. Then after that, I will teach you something called remainder theorem. We will learn something about this, but we will handle that later. So the question is x power 3 minus 7x squared plus 5x minus 4, and then we divide by x minus 1. Very quickly, we use this divide by this, we get x squared times x power 3, x squared times negative 1 negative x squared. And then we have the subtraction, negative 7 minus negative 1 will get negative 6x squared plus 5x. And then again, we repeat the cycle. Negative 6x is the quotient, and then negative 6x times x, negative 6x squared, negative 6x times negative 1, we got positive 6x. And then subtraction again, 5 minus 6, we got negative 1x, or just negative x. That means negative 1x divided by x, we got negative 1 here. And then negative 1x, negative 1 times negative 1, we got positive 1. So we have the remainder, which is negative 5. And then we answer the question here. The quotient is x power 2 minus 6x minus 1. And then we use dot 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 to represent the following is the remainder, negative 5. You may feel a little bit strange. Our remainder is a negative value, but it's totally fine in polynomial division. We just need to make sure that the power of this remainder is less than the divisor. Then it's fine. And then how it is related to the remainder theorem just now is remainder. Just now we have a long calculation in order to get the quotient and the remainder. But however, if we just need the remainder, then there is our theorem. That means remainder theorem, to let you very quickly, directly find out the remainder in this situation. Before I explain why we have that method, but let me tell you the method and how to apply the method first. When the function, that means x power 3 minus 7x squared plus 5x minus 4 divided by x minus 1, then the remainder will equal to, you put a suitable value, suitable x, in order such that divisor becomes 0. This is the criteria, and you need to memorize first, otherwise we can't continue. In the coming video, I will explain why we can use this theorem, why we have this theorem. But now you just trust me that we can put a suitable x inside the original function, and then the values will become remainder. Now we are going to verify, see whether it is consistent in this question. So we consider when x is equal to suitable value. What is the suitable value of x will make this become 0? What minus 1 equals 0? Of course it is 1. So now I replace x by 1. And then the function will become something power 3 minus 7 something plus 5 something minus 4. This is 1, 1, 1. And then we are going to check, will the results really our negative 5 here? So minus 7 plus 5 minus 4. This is negative 6, and then this is plus 1. We got negative 5. Oh, it seems like magic. At least it's very weak evidence, but at least I proved that this kind of theorem help us to find out the remainder, which is negative 5. And then it's also consistent in other situations. The criteria is, you have to remember, we are putting a suitable x to make the divisor become 0. we put x inside our original function. Our original function.